Now let's start our discussion on the combination. So our combination of elements of a set is an unordered selection of R elements from the set. Thus, our combination is simply a subset of the set R with R elements, of the set with R elements. So here what you note is that it's unordered, therefore order does not matter here. Secondly, whenever you have to make a distinction between the combination and the permutation, one of them is the notation, the way they are represented. Just like the permutation is represented with P, combination is represented with C. So we'll have NCR or CNR or also NR. So they all mean the same thing, and this is also called as the binomial coefficient. Binomial coefficient. Now, let's choose S to be a set which has the elements A, B, C, and D. And let's say we have to find the two combination. So we'll find all the pairs. But the second thing worth noting here is that unlike permutation, the combination in combination the order is not important. So if you try to note down all the pairs A, B, A, C, A, D, B, C, B, D, and C, D. So we do not have something like BA also here. So we do not have something like that, or CA. Likewise, DC, because this and this, they both mean the same thing. So this is what is meant by the order. If it were the permutation, then BA would be a different entity than AB, or CA would be a different entity than CA, and all of them will be mentioned. So since in combination both mean the same thing, therefore only one of them is mentioned. And likewise, what we find is we have 1, 2, 3, 4, 5, 6 of these combinations. Now, mathematically, if you have to count the number of combinations, then if we have n elements, and such that R hovers between n and 0, then we'll have the expression for the combination as CNR, which is the representation, or you can represent it any of these three ways, this, or this. Is equal to n factorial divided by n minus R factorial times R factorial. So it's something, a part of it is like the combination. So this was the definition for combination. And we have this part added to it. So you can say times 1 by R factorial. So this part is common with NPR or permutation. Now let's take a look at one example. So how many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Also, how many ways are there to select 47 cards from a deck of 52 cards? These are basically two problems. We know here order is not mentioned, therefore order is not important, and hence this is the problem where we will use combination. So there are 5 cards and there are 52 standard cards. So we'll have is 52C5, or this is the same thing, is equal to 52 factorial n factorial divided by n minus r factorial, which in this case is 5, and minus r will be 52 minus 5 factorial, and then we have r factorial 5 factorial. So this will be equal to 52 factorial divided by 47 factorial times 5 factorial. So this will give us 52 times 51 times 50 times 49 times 48 times 47 factorial divided by 47 factorial times 5 factorial. So this and this will cancel out. Then 5 factorial will cancel out with this, and what we'll get is, while we simplify this by cancelling out 5 factorial, let me write it here so that there is no confusion. 5 times 4 times 3 times 2 times 1, and here we have 52 times 51 times 50 times 49 times 48. So we know this will be equal to 4, 1, 4, 12, then 2, 25, likewise 3, 17, and then 5, 5. So the number that we'll get after the simplification of this is multiplying 52 times 17 times 5 times 52 times 17 times 5 times 49 times 12. What we'll get is 2598960. So these many permutations are possible. Now let's have a look at the other one, where how many ways are there to select 47 cards from a deck of 52 cards. So here Rn is 52 and R is 47. So we'll get is 52 factorial divided by 52 minus 47 times 47 factorial. So this will be equal to 52 factorial divided by 5 factorial by 47 factorial. So if you look at this and what we obtained earlier, both are the same. So 52 is in the numerator and 47 and 5 are in the denominator. So we'll get the same number of combinations. Now this is one of the special cases where both of them are equal. Now to make sense of this, Let's try to prove it. We know that in a generalized way, the combination is equal to CNR is equal to n factorial divided by n minus r factorial times r factorial. Let's say we have C n and n minus r. This is a combination. So what we'll obtain is, using this formula, what we'll obtain is n factorial divided by n minus r. For n minus r, we'll have n minus r factorial times, for r we have n minus r factorial. So if you simplify this, this will be n factorial divided by n minus n, this will cancel out, so there will be r factorial times n minus r factorial. So both are the same. So this and this both are the same. So that's why in the last problem we got the same number of combinations. So we discussed some problems related to combination. Now let's try to make a distinction between how the combination is different than the permutation. In fact, let's do it in the next video.